Data types are a fundamental part of your tables and your data storage in SQL Server, and I want to make sure that I go over data types thoroughly with you because they're so vitally important from an administrative standpoint as to how the data is first of all stored and how the integrity is maintained in your database, and also it has to do with the efficiency of retrieving the data from your database. And I'll explain that later when we talk about how SQL stores data. I've mentioned that about 400 times now, and you will see it a little bit later on, but it's really kind of a cool thing. Notice when we created a table, graphically, it was real easy to see. I gave a column name, and then I said what kind of data I'm going to store in that column. And there was a drop down here, and there were a lot of different choices. Well, how do I know which particular data type should I use? Well, here's what we're trying to do. You want to choose a data type that has enough room for what you need to store, but not too much room. We do this all the time with the houses we buy. How large of a house do we want? Well, we want one large enough to store all of our stuff and give us room to do what we want to do with our lives, but there's no point in buying a $4 million house if we don't need that much room, and if you don't have the $4 million bucks. But we're doing the same thing here. We want to be as efficient as we can on storing our data, but not leaving ourselves too much room that wastes space. This will affect the efficiency and speed with which SQL can retrieve data from our database. So with that, let's go out and look at the data types and go through them. And I want to just give you a kind of an overview of the various data types you have to choose from. Now, SQL divides the data types that are available into categories, and those categories are exact numerics, approximate numerics, date and time data types, character strings, Unicode character strings, and binary strings, and there's a couple of others that I'll talk about. Now, I will divide these data types into two videos because there's too many to talk about, and the video would just be way too long. So we'll do a few of these and then do a second video for them. First of all, let's look at the exact numerics. Now, the first choice you have is big integer, and notice the size number you can store in a big integer data type. It's a bazillion or a gazillion or whatever. But notice you can store a huge number in a big integer data type. So why not always use that? Well, it uses 8 bytes of memory to store that number. So if you use a big integer and store the number 26, you're using 8 bytes of memory to store just a really small number. So that's not very efficient. The next type down is an integer, and notice it's roughly from -2 billion to +2 billion. And so if you're trying to maintain numbers that won't exceed +2,147,483,647, you can use the integer data type. Note, this one uses 4 bytes of memory to store the data. Small integer, we're coming on down now for numbers between negative and positive, roughly 32,700. We can use the small integer data type, and this one gives us takes 2 bytes to store this data. Coming down from there, tiny integer will store from numbers 0 to 255, whole numbers only, of course, and it uses 1 byte. Now, what happens if I designate tiny integer and then try to store the number 256 or 300? I will get an overflow error, and it will tell me that the data type, there was a data type overflow. It wouldn't hold the data, it wasn't large enough. So you have to do a fair amount of forecasting to be able to choose your appropriate data types. A bit, this one's interesting. A bit data type stores a 0 or 1, and these are real useful, very useful, I should say, for storing on-off columns, indicator columns, and so forth. And true and false can be converted to 0 or 1. Now, they've made a change in 2005, in SQL 2005, and that change is for the efficiency of storing these bit data types. Once you choose to use a bit data type, it's going to use 1 byte of memory, which is, of course, 8 bits. So what will happen is, for the first 8 bits that you use as data types in a table, it will use that same byte to store each of those bits in a separate bit within that 8-bit byte. I don't know if that made any sense or not. Play it back again and again and again. But bottom line is, once you use a bit, they set aside 1 byte, and then you have up to 7 more bits that you can use, and then you will jump into using another byte of data. So if you use 9 bits or more, you're going to use 2 bytes. Hope that makes sense. Now let's talk about exact numerics. If you need to store exact, precise numerics, you can use the decimal data type. This gives you a maximum precision of 38 digits to the right or left of the decimal point, and if you use all of those precision points, you'll use up to 17 bytes of data. There's a numeric data type, but it's functionally equivalent to decimal, so just use decimal. Now, at that point, let's stop this video, and I'll join you again in the next video, and we'll finish up the data types.